Hello folks, and how are you all doing? So in this video, we will be coding this very simple RPG-like character that you can see over here. And we can move the character like in many RPG games we see, like Pokemon, Zelda, Dragon Ball Z, or even the newer games like Moonstone Island or Stardew Valley. There is character animation, and in this video, we will learn how we can do that. And also, as you can see, when the character is idle, there is also some sort of idle animation. Now, for the purpose of this video, I will not be drawing the character. I have already done it in a very cool software called Sprite. You can definitely check it out. What we will be doing is we will be coding. So we will code and see how by pressing buttons we can move the character. And I have opened my VS Code where I have a very self-explanatory index.html file. We have a canvas with some background color of light green. This will look like grass, and we have a black border around it, and this is how it looks like. And we also have our sprite sheet. This is our sprite sheet that I made in Sprite. I have shown you before. And we have total 16 sprites. So the first row is that of our forward walking. And then the second row is that of our idle state. Then we have a backward walking, and we have walking towards left. And by flipping this, it will become walking towards right. I believe it's opposite. So this is right walking, and by flipping it, we will get the left. And we have connected the script.js file, which is empty for now. And this is where we will start by declaring our canvas. So canvas equals to document.querySelector canvas. And we then have to create a context where we will draw. So this will become canvas.getContext 2D. And let's also define the width and height of our canvas to be 500 and 500. And now, if we go back to our browser, this is how it looks like, a large lawn for our character to walk around. Next, we have to define our image. So const player image equals to new image. Then we have to set the path of the player image. So this is our girl sprite 0003.png. And now we have to define some dimensions. The first one being total image height. For me, this is 1280. So the total image height means the height from the top pixel to the bottom pixel. And how do I know this is 1280? Very simple. We have to open our file explorer. So explorer dot, and we will get this one. Now in the code, I have this image. If I go to properties, so show more options and properties, and in the detail section, we will have 1280 pixels width and height. So this is how we get it. Very simple. So the same is true for our height also. So total image width. So same is true for width. And now we have to get our sprite height. This will be divided by 4. So 320. I'll write directly. And then the next one will be sprite width. So there is a different way of writing this so that this is more accurate. But since we are dealing with a fixed sprite sheet, we can write it. So if you have a more complex software, maybe you can do total image height by 4 or something like that. Now the next thing we will define is something called a scale. This is 0.25. What this means is, so we have the sprite height to be 320, but we don't want such big sprites in our browser. We want a smaller sprite like the one you have seen at the beginning. And so we are defining the scale. And so we will get a scaled width. This is nothing but our sprite width multiplied by our scale. And same is true for the scale height. So let me change it to height. So these are some dimensions that we will need in the future. And now the next thing that we will define is our player. So the player will have some characteristics, and that we will define here in the form of an object. So the first things first, we need the x and y. So what is the x and what is the y? So we can consider this initially as the starting position. So let's say I'm starting the character at the center of the center. So let's say, so we will do canvas dot width divided by 2, and the height will be canvas dot height divided by 2. Very simple. Now, another thing is this is exact center point. So our character will be drawn at the exact center point, but the character is also of dimensions 80 cross 80. So the ideal case is minus 40 and minus 40. Now we won't write it like this. We want to be more picture perfect, you can say, for this one. So we'll do a scale height by 2 and scale width and scale height by 2. Then we will define a speed. So the speed our character will walk, and we also need to define the frame in the x and y. So frame for the x is 0, and frame for the y, initially I will set it to 1. Now what this means is, so the frame x is our x-axis, so 0, 1, 2, 3, and y is the y-axis, 0, 1, 2, 3. Now why I'm setting the y frame to be 1 is because initially I want our character to be idle, and so we are choosing this to be 1. Then we need to define the max frame. So how many frames we have? We have 4, so we have defined it. Now we need to define a frame timer. Frame timer, let's start with 0, and the frame interval, let's give it 10 for regular cases. Now for the idle character, I want a larger frame interval, so idle frame interval, let's give 30. So what this means is, uh, at a speed of 10 our characters will animate when they're walking, but uh, when they are idle they will animate at the speed of 30. Now this is actually the opposite. So when we will code, you will see. So our idle frame will be slower than our walking frames. Now why we need this? You will see when we code, we will come across some problems. So we need this thing. And then we will define one more thing is if the character is moving or not. So initially the character is not moving, so moving will be false. And we will also give a direction. So direction initially is idle. So this is the state of our player initially. Now we also need to define some modes of animation. So animations. So we generally have 5 modes, I believe. So the first one, so let's rank them sequentially. So forward walking is 0, then idle is 1, then backward walking is 2, then rightward walking is 3, and we will also have 3 for the left also, but that should be flipped. So let me write walk down, because the forward is also walking down, and then the idle is 1, then our walk up, the backward is also walking up, this is 2, and then walk left and walk right both are 3. So walk right is 3, and walk left, this is also 3. So we have our modes of animations, and next things that we need to define are some add event listener. So key down, and to work with our add event listener, so whenever we are pressing the key down, our character is walking, we also need to define some keys. So we'll define keys to be, so there are 4 keys: W, S, A, D. We can also use arrow keys, but I prefer this one. So initially none of these keys are pressed, so all of this will be false. False, 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 and D is also false. Now for the key down, we have 4 cases for the 4 keys, and so what we will do here is we will take switch, and we'll take the E dot key. Now why we are taking the E dot key? Because if we simply do a console log of key, and let me go back to my browser, let me open inspect console, and now WSAD, and as you can see the key value is WASD and whatever, and so we can get it like this one. So we have a case for W, then we will have a case for S, and we also need to break. And we will do this thing. So keys dot w, this will be true, and then the break. So for the s also similar thing. So let me just copy. I don't want to write again and again. So in place of the w, this will be s, and then comes, this is the a, and lastly for the d. So whenever we are pressing, the keys pressed will be true, and when we are releasing the key, this also need to be made as false. Otherwise, when we press W, the keys dot W will be true forever. So we need to do for the key up also. So for the key up, all of these things will be false. So all of these are made to false. Yes. So now our basic controls and our basic variables, all of these things are done. So the next thing that we need to do is we need to run a game loop. And I will call this function animate. And here we need to do a request animation frame. This is something that we do for animate. And we will do the animate. So what this means is if I do a console log here, console log of 1, so the 1 will show up repeatedly. This means that this function is repeatedly calling itself. And so this is something that we can make use of to animate our character. So let's see how what we can do. So this is a game loop that is running. Now inside the game loop, we need to do a few things. So we need to update the values of our character. For example, the character has an X and Y and which direction or mode, or so the character has a lot of values. So we need to take care of that. So we expect a function called update player inside the game loop. And we also need to draw our character whenever our character is moving. So we also expect some function called draw player. So now it will show some errors because there is no update player or draw player. But we will write the function, so there will be no issues going forward. So let me write two functions. So function update player and another function called draw player. And the errors are gone, but we don't have any character because we haven't drawn any character. So let's see what we can do inside the draw character. So let's draw our character. And drawing is very simple. We have to simply do ctx.draw image. Now the draw image accepts 9 parameters. So what are the 9 parameters? The first parameter is the player image that we have defined at the top. You must remember this one. And now we are left with 8 parameters. So what are the 8 parameters? It's actually very simple, sounds a lot, but very simple. And MD and docs explain this very quickly. So these are the 8 parameters. So we have a source image and we have to cut a rectangle from the source image. So what does it mean? It means we have to define an x and y and a width and height, and it will cut a rectangle from the source image. Now, what is the source image? In our case, it is our girl sprite sheet. So let's say we want to take this sprite over here. So this means we have to take the x and y at the plus icon, whatever it might be. It is, I believe, 320, comma 320. And we have to take the sprite width and the sprite height, again 320, comma 320, I believe. And we have cut one rectangle. And then, so let's first write these 4 parameters and then we'll see what the next four are. So what is the x value? So the x value is player dot frame x. We have defined it to be 0. Frame x, and we have to multiply by the sprite width. And then the next parameter is player dot frame y. This is 1, and we'll multiply by the sprite height. And then we have to define the width and the height. This is nothing but the sprite width and the sprite height. So what this means is we have taken the x from here and we have taken 1 multiplied by the sprite height from here, and we are giving the width and the height, which basically means this we are taking the sprite. So this is our first 4 parameters, and the next 4 parameters are the same things. We will draw a rectangle in our destination canvas. So we need an x and y and the width and the height, and this is our destination canvas. So very simple once again. So our player has some x and y. So player dot x and then player dot y. This is at the midpoint of our canvas. And then the width and the height is basically our scale width and height that we defined initially. This is 80 and 80. And now if we go back, we have a character exactly at the center of our canvas. So we have drawn our character, and this is very simple, but the character is not moving because we have only drawn one sprite. And we will see very soon how we can move our character using our update layer. Now we have drawn our image, but we also need to do few more things. We have to do ctx.save and a ctx.restore. Now we are drawing this particular image, this particular image. Um, so we have basically four categories of sprites here: the walking forward, idle, walking backward, and the walking right. The walking left is not present here, but we have to include that somehow in our draw player. So how we can do that is, first of all, we have to check the direction of our player. So player.direction, we have defined something like this. So right now it is idle. So when the player.direction is our walk left, this is walk left, right. We have the animation for walk right. We want to do something else. In all other cases, we want to do what we were doing, that is ctx.draw image and the normal drawing. Now, in the case of our walk left, what do we want to do? We want to do this, but not exactly this. Before that, we need to do something. We need to do a ctx.scale and the x and y, so -1 comma 1. This is something that is flipping our image. I mean, that will flip our image. We'll see this soon. And then in the draw image, player image is fine. Player dot frame x, frame y, these things are fine. We have to pick the exact image. So for the source, it is fine. But for our destination, we need to write it in a different way. So we need to do it like this. So minus player x plus our scale width. And now if we go to our canvas, it is still our player. But if we change it to walk left, and let's see what happens. So walk left. So something strange happened here. It is not exactly our walk left, and that is because our walk left has a y of 3. This is something we will get from our animations. And so the animations is tagged with walk down, idle, walk up, and these names. And these are the same names that we are taking in our direction. The number is 3, so we have to give the frame y of 3. And now we have the player facing left. Now, if you see, our sprite doesn't have a player facing left. It has a player facing right, but here our player is facing left. So we have achieved our walk left, not exactly walk left. We have achieved stand left. So let's not do it right now. Let's keep things as it is. But this is something that we had to add in our draw player because eventually we will need this. So we once again have the idle stand. Okay, so we have our draw player. Now let's do our update layer. So let's update the values so that we have some sort of motion. So what things do we need to do in our update player? So how will we update our player? So we will press our keys, for example, WSAD, and the values will become true. And when the values are true, the player will start walking. That is what we expect. And then these values will once again become false. So, um, so whatever is the case, let's start by trying to animate something. So we have a player dot frame timer, frame timer, and we will keep on adding this one. And then let's do a current interval. So we have two kinds of intervals. So one is for our frame interval. This is the regular interval, and another one is for the idle frame interval. So for the idle, we want a different speed, and we will see what happens when the speed is same. So here, first of all, we need to check what kind of interval we want. So we need to check what is our player dot moving. So if our player dot moving If our player dot moving, so this is either true or false. So if we are idle, then the player dot moving should be false. So if our player dot moving is true, then we want our player dot frame interval. And in if this is false, so simple ternary operation we are doing. And if this is false, we want the other one. So player dot idle frame interval. So right now this will be 30. If we simply do a log of current interval, we will see the value is 30, and this is true for our idle step. Now, then what do we need to do? Then we are improving our frame dot timer. So we will check what is our timer. So player dot frame timer. If this is, let's say, this is more than our current interval, uh, we need to restart. So when our player dot frame timer is reaching 30, we want to do our animation. So we will take 30 frames for animating our idle position, and as it will happen. So we need to change our player dot frame x. So frame x. So it will change to what? So frame x is basically this one. So this 1, 2, 3, 4. So we want it to go from 1 to 2 to 3 to 4. And once it reaches 4, we want it once again to be 1, 2, 3, 4 like that. And so how can we do this thing? So we have to do player dot frame x plus 1, and times 4. But we won't write 4 like this. We'll do player dot max frame, and the max frame value is also 4. So what happens in this case? So we have 1, 2, 3, 4, and then because it's a modulo function with like modulus by 4, it will once again become 1, 2, 3, 4, and we will also restart the frame timer. So player dot frame timer should be equals to 0. Now let's see what happens. And we see some animation working, but there is some slight issue. If you see the top portion, let me take a different one. So instead of the idle, let me take the work right. And now, okay. So for some reason, it is not doing the work right now. And the reason is very simple. We are not changing the y. So if you see, it is actually overwriting a lot of characters. So it is not deleting the older one. So that is the problem. So let me change it to idle. And this is happening because we are repeatedly drawing the players. So after drawing the player once, we need to clear our canvas. So we'll do ctx.clear rect 0, 0, and then canvas dot width and the canvas dot height. So this is something that we need to do. So now if you see, we have a very simple idle animation. Now, how is it working? So, how is it working is it is counting from 0 to 30, and it is animating the character within those number of frames. Now, let's say both frames were equal. We didn't take an ideal frame. So let's say both are 10. Then what would happen is something like this. Now, this is not bad actually. We can take this one. This is also quite good, but what I want is when the player is idle, I don't want the player to move so fast. So I have taken two. Like when you're idle, why would you move like this? So only when, let's say, only when you are breathing, there is some natural movement, and you don't want to be restless when you are idle. So let's keep it at that. So we have some basic movements. So our draw player function is, you can consider it to be done. So we will change our like player x and y and those values over here, and our player like draw player function will draw accordingly. For walk left, it will take care of the flip using ctx.scale and a different value in our destination canvas. So it will take care. So the main thing that we need to do, the main logic of our program will be inside the update layer, and then we can consider it to be done. So now, what we want to do is we want to check which keys we are pressing, and accordingly we want to move. So if keys.w we have, we want to do something. Else if we are pressing the keys.s, we want to do something else. And this is else if we are pressing the keys dot A, we want to do something else. And lastly, we have else if we are pressing the keys dot D, we want to do something else. And finally, this is our idle case. So in our idle case, what we want to do is we will simply change the player direction to be idle, and also the player moving to be false. So player moving to be false. Now, for when we are pressing W, what do we want to do? We want to change the value of our y. So this should be uh, subtracted with the player dot speed. So we have made a speed of 3, right? So now if we do press W, so something is happening, right? So our player is moving at the top, but it's like in the idle position. This is not half bad, but this is definitely not what we want. So why is this happening? This is happening because we are only changing. So in our update, where is the update? Huh? So we are only changing the value of the y, but we also have to change our frames. So this is the reason this is happening. So we have to change the player dot direction to be a walk up, and player dot moving to be true. And also we need to change our frame y. So we'll do a player dot frame y. So what do I want my frame y to be? I want my frame y to reflect my walk-up. So I have animations, and inside I want to find the value of my player dot direction. So player dot direction. So right now it is walk-up. So what this means is our player dot frame y will be equals to the player dot direction value of our animations. So in our animations, I have a walk-up, the value is 2, and player dot animations is 2, so the value is 2 basically. So our frame y will be 2. 2 basically means this row, and this correctly represents the sprites that we want to show when we are walking up. So now if I press W, our player is walking up, but there is still another problem. That is, our player is not respecting the boundaries of our canvas. Now later we will see how we can change a scene, because in RPG games there are lots of scenes, and it will be terrible if our game is limited only to one scene. But for the purpose of this video, I want my player to respect the boundaries of the scene. Scene change is something we'll see later. Consider this thing to be some sort of an arena. Like in RPG games, we have the arena mode, right, where we fight. So consider something like that. And I want my player to respect these boundaries. So how can we do that? That is very simple. Um, Whenever we are pressing W, we are going up. And here we also need to make sure that the player.y is never becoming less than 0, so it should always be greater than 0. Now it will go up, and whenever it reaches the boundary, it is once again in an ideal state. So this is good for now. So let's quickly also implement the left, down, and right, and other movements. So for the keys dot s, it is very simple. We have to do player dot y plus equals to player dot speed. Then we also need to change the player dot direction to be. This is walk down, and then we will change the player dot moving to be true. And let's also implement our boundaries. So player dot y should always be less than canvas dot height minus my scaled height. Now let's do for our a. So this is left moving. So in this case, our player dot x should be minus equals to my player dot speed. Then player dot direction should be what? Should be, I believe this is walk left, right? Not right, left. And player dot moving should be once again true. And let's also implement our boundaries. So in this case, we need to make sure that the player dot x is always greater than 0. Lastly, we will have our d. And so the left was where we are flipping our character. So let's test once it's correctly working or not. So upward is fine, downward is also fine. So yeah, so we have little bit of a movement. I mean, yeah, this is how I have drawn the sprite. So And the left is also working fine. The right is not yet because we haven't written anything. So now for our right, very simple once again, player dot x plus equals to player dot speed. Then player dot direction is what? Is walk right. And lastly, the player dot, what is the player dot moving is true. Let's implement a constant, and that is the player dot x should be less than the canvas width minus my scaled width. Yes, and we have a very simple, not an RPG game, but an RPG game character. So our character is moving well. So yeah, so I think this is a fun project. And going forward, we will see a lot of new things like how we can change scenes and how we can add more assets and many more things. I may even draw some characters. Let's see. So my plan is to build something like a game maker, something like an RPG maker for the browser, where we can drag and drop objects and we can let's see how far we can go. So that's it for this folks, and if you have liked the video, so make sure to like, share and subscribe. It helps me grow the channel, and I will see you soon with another very interesting video. So see ya.